IRC 37 Flexible Pavement Design Part-3 Overview. Welcome to Civil Engineering Infrastructure. This is Part 3 of the IRC 37 Flexible Pavement Design series. In Part 1 we understood the basics and layers. In Part 2 we understood material, CBR and pavement response. Now in Part 3 we will understand design logic, pavement failures, construction and quality control. This Part 3 we will cover the complete overview from slide 21 to slide 30. Section 8. Part Introduction. Slide reads: This is Part 3 of IRC 37 Flexible Pavement Design Series. And this section focuses pavement design logic, failures, construction, and quality control. The engineering note clearly states that design accuracy and construction quality directly control pavement performance. That means only when the design is correct and the execution is correct, the pavement will become durable. Section 2. Content structure. Now topics are given in the table from slide 21 to slide 30. Pavement design principles in slide 21. That means layered system behavior. Fatigue failure concept in slide 22. Cracking due to repeated load. Rutting failure concept in slide 23. Permanent deformation in pavement. Section 2. Content structure. Now topics are given in the table from slide 21 to slide 30. Pavement design principles in slide 21. That means layered system behavior. Fatigue failure concept in slide 22. Cracking due to repeated load. Rutting failure concept in slide 23. Permanent deformation in pavement. In slide 24, pavement thickness design. Layer thickness selection. In slide 25, reclaimed materials. Sustainable material use. In slide 26, overlay design basics. Existing pavement को strengthen करना. In slide 27, shoulders and edge support. Lateral stability. In slide 28, construction considerations. Site execution practices. In slide 29, quality control requirements. Testing and inspection. Flexible pavement failure modes in slide 30. Different types of distress. Section 10. Learning outcome. After this part you will understand pavement design logic, failure mechanism, thickness selection, construction practices, and quality control importance. This means that now you will be able to relate the design to practical site conditions. Section 4. Pavement failure concepts. Now failure concepts are given on the right side. Fatigue failure. Due to repeated load, tensile strain develops at the bottom of the bituminous layer, and cracks develop. Rutting failure. Repeated load causes permanent deformation in the pavement. A depression is created in the wheel path. Edge failure. Poor shoulder support causes edge cracking and breakup. Overlay concept. Strength and life are increased by adding a new layer over the existing pavement. Section 5. Shoulders and edge support. The shoulder support diagram is given below. Good shoulder support provides lateral stability and prevents edge failure. Section 6. Construction activities. Now construction activities are shown. Grader, paver, roller. This equipment is used for proper layer construction. Section 7. Quality control tests. Now quality control tests are given. Density test, thickness check, core sample, level check. All these tests ensure that the construction is happening as per the specification. Section 8. Flow understanding. Now let us see the flow understanding diagram. Design starts with concept. Then let's check the failure criteria. Then do thickness selection. Then we use material. Then construction takes place. And finally there is quality control. That means this entire sequence decides the pavement performance. Section 9. Failure modes. Now flexible pavement failure modes are given below. Alligator cracking, rutting, raveling, potholes, stripping, reflective cracking. These are all pavement distress types that develop due to design or construction issues. Section 10. Practical engineering note. Now practical note is very important. Poor design leads to early failure. Reduces pavement life. Weak shoulder causes edge cracking. Defects develop if there is no quality control. Section 11. Bottom summary. Now the summary is given below. In Part 3 we cover design, failure, and construction. And the most important line is proper design means durable pavement. Key takeaway. Good design gives strength. Understanding failures prevents distress. Quality construction increases pavement life. Quality control ensure reliability does. So friends, in Part 3 we understood the complete overview of design, failure and construction. The next part, we will understand the IRC, SATI's design procedure in more detail with further slides. Stay connected with Civil Engineering Infrastructure. Thank you. SLID 21. Overlay design in flexible pavement. So friends, till now we have understood pavement design, fatigue failure, drainage, recycled pavement, and sustainable pavement concepts in detail. But a very important question arises in practical highway projects. When the existing pavement becomes weak, so is the entire pavement reconstructed? Not every time. In many cases, a new strengthening layer is provided over the existing pavement. And this process is called overlay design. And this entire concept is explained in detail in this slide. So let us understand the entire slide step by step. Introduction to overlay design. What is overlay? Overlay is an additional pavement layer, which is provided over the existing pavement, so that structural strength and riding quality can be restored. When the existing pavement becomes weak due to traffic loading and environmental effects, then the overlay is provided. See the engineering note below. Overlay improves pavement life without complete reconstruction. The life of the pavement can be increased without breaking it completely. And this is the most common method in highway rehabilitation projects. Now let us look at the second topic. The objectives of overlay design. The main objectives of providing overlay. Restore pavement strength. Improve riding quality. Increase service life. Reduce maintenance frequency. Strengthen weak pavement sections. And this is the main purpose of overlay rehabilitation. Now let us look at the third topic. 10 causes requiring overlay. Now let us understand why overlay is needed. Fatigue cracking, rutting, surface deformation, potholes, loss of structural capacity, increased traffic loading. And these pavement failures are shown in the right side images. Now let us look at the fourth topic. 4 types of overlay. Now let us understand the major types of overlay. A. Bituminous overlay. Asphalt layer is provided over the existing pavement. B. Structural overlay. Increases load carrying capacity. C. Functional overlay. Improves riding quality and surface condition. And the overlay type is selected according to the project requirement. Now let us look at the fifth topic. 5 overlay design parameters. ओवरले थिकनेस डिजाइन किन पैरामीटर्स पर डिपेंड करती है? एग्जिस्टिंग पेवमेंट कंडीशन, ट्रैफिक लोडिंग, डिफ्लेक्शन वैल्यू, रिमेनिंग पेवमेंट लाइफ, सबग्रेड कंडीशन. Now see the important points below. Deflection survey is important for overlay thickness design. And deflection survey is very critical in practical design. Now let us see the right side overlay construction process. Step 1. Damaged existing pavement. Step 2. Milling operation. Step 3. Tack coat application. Step 4. Sensor paver overlay laying. Step 5. Roller compaction. Step 6. Strengthened pavement. और यही complete overlay rehabilitation process है. Now let us look at the sixth topic. The remaining pavement life. Residual structural performance is evaluated. On the basis of these parameters, the overlay thickness is decided. Now look at the Benkelman beam diagram below. Pavement deflection measurement is being done when wheel load is applied. And this is the important input of deflection overlay design. Now let us look at the sixth topic. 6 overlay design procedure. Step 1. Conduct pavement condition survey. Step 2. Measure pavement deflection. Step 3. Evaluate traffic loading. Step 4. Determine overlay thickness. Step 5. Select overlay material. Step 6. Execute surface preparation and overlay laying. And this is the standard overlay design sequence. Now let us look at the seventh topic. 7 surface preparation before overlay. Proper surface preparation is very important before overlay construction. Crack sealing, pothole repair, surface cleaning, milling of damaged layer, tack coat application. Now see the engineering note below. Proper surface preparation ensures strong bonding. And strong bonding is the most important factor for overlay performance. Now let us look at the right side flexible pavement overlay layering system. The new overlay layer is shown above. There is existing pavement below it. Then granular base, granular sub-base, and compacted subgrade is shown. And the load is being distributed from top to bottom. Now let us understand the concept of reflective cracking. Due to good bonding, load transfer takes place properly. But due to poor bonding, debonding and separation starts. And this overlay is what develops distress. Now let us look at the reflective cracking mechanism. Existing crack is present below. Then the crack propagates upwards. And finally the overlay becomes visible on the surface. This is called reflective cracking. Now let us look at the ninth topic. Now important engineering concepts. Overlay thickness depends on residual pavement strength. Improves structural performance. Reflective cracking may be visible in the overlay. Increases overlay life. And these concepts are most important in practical rehabilitation design. Now let us look at the 10th topic. COMMON overlay failures. Reflective cracking. Debonding. Rutting. Slippage cracks. Surface undulation. And these failures develop due to improper construction. Now let us look at the 11th topic. 1. Practical site observation. Creates an uneven riding surface. Poor tack coat causes overlay separation. Existing cracks reappear if not repaired. Heavy traffic demands thicker overlays. And these practical issues are most commonly observed during site inspection. Now let us look at the 12th topic. 1. QULITY control requirements. QC is very important in overlay construction. Overlay thickness checking. Temperature control. Density testing. Surface level checking. Tack coat quality. And proper compaction increases overlay durability. Now let's see the interview question box. Q. Why is overlay provided? Answer. To improve structural capacity and pavement service life. Q. Which test is commonly used for overlay design? Answer. Benkelman beam deflection test. अब नीचे वन शॉट रिवीजन देखते हैं. Overlay. Pavement strengthening layer. Deflection survey. Existing pavement evaluation. Good bonding. Better overlay performance. Poor surface preparation. Overlay failure. See the final message at the bottom. Recycling today. Sustainability tomorrow. Stronger roads forever. CI family. If you find highway rehabilitation and pavement strengthening concepts useful, so please like the video, subscribe to the channel, and press the bell icon, so that such complete highway engineering lectures can be available continuously. And in the next slide, we will understand pavement performance evaluation and distress analysis, where we will understand pavement condition survey, distress identification, and failure evaluation concepts in detail. SLIDE 22. Overlay design in flexible pavement. So friends, in the previous slide we understood the basic concept of overlay design. But now in this slide, we will understand the overlay strengthening process in detail in a more practical way. Why is overlay given? How is it designed? What failures occur? And what precautions are necessary during construction? This entire engineering concept is explained in this slide. So let us understand the entire slide step by step. एक introduction to overlay design. Overlay is an additional pavement layer, which is provided over the existing pavement. What is its purpose? Restoring structural strength, improve riding quality, and the most important thing, overlay improves pavement performance without full reconstruction. This is why overlays are widely used in highway rehabilitation projects. See the engineering note below. Overlay extends pavement service life economically. This means that pavement life can be increased at a comparatively low cost. Now let us look at the second topic. No need for overlay. Overlay needed. Increase structural capacity. Improve riding quality. Repair surface distress. Increase fatigue life. reduce maintenance frequency. And these are the most common reasons for providing overlays in practical highways. Now let us look at the third topic. 3 types of overlay. Here are the 3 major types of overlay. A. Bituminous overlay. Asphalt layer is provided over the existing pavement. B. Structural overlay. This increases the pavement load carrying capacity. C. Functional overlay. This improves the riding surface and smoothness. And the overlay type is selected according to the project condition. Now let us look at the fourth topic. 4 causes requiring overlay. Why is there a need to provide overlay? Fatigue cracking, rutting, surface unevenness, loss of riding quality, increased traffic loading, aging of pavement. And as the traffic loading increases, the existing pavement starts becoming weak. Now let us see the right side overlay operation process. Step 8 is cracked and in distressed condition. Step 2. The damaged layer is removed by milling operation. Step 3. Tack coat is applied for bonding. Step 4. Overlay paving is done with sensor paver. Step 5. Proper density is achieved by roller compaction. And this is the complete overlay rehabilitation process. Now let us look at the fifth topic. 5 overlay design parameters. On which parameters does overlay thickness design depend? A. Existing pavement condition. Structural strength evaluation is done. B. Traffic loading. Future cumulative MSA is considered. C. Pavement deflection, which is measured by Benkelman beam or FWD. D. Remaining pavement life. Residual structural performance is evaluated. On the basis of these parameters, the overlay thickness is decided. Now look at the Benkelman beam diagram below. Pavement deflection measurement is being done when wheel load is applied. And this is the important input of deflection overlay design. Now let us look at the sixth topic. 6 overlay design procedure. Step 8. Conduct pavement condition survey. Step 2. Measure pavement deflection. Step 3. Evaluate traffic loading. Step 4. Determine overlay thickness. Step 5. Select overlay material. Step 6. Execute surface preparation and overlay laying. And this is the standard overlay design sequence. Now let us look at the seventh topic. 7 surface preparation before overlay. Proper surface preparation is very important before overlay construction. Crack sealing, pothole repair, surface cleaning, milling of damaged layer, tack coat application. Now see the engineering note below. Proper surface preparation ensures strong bonding. And strong bonding is the most important factor for overlay performance. Now let us look at the right side flexible pavement overlay layering system. The new overlay layer is shown above. There is existing pavement below it. Then granular base, granular sub-base, and compacted subgrade is shown. And the load is being distributed from top to bottom. Now let us understand the concept of reflective cracking. Cracks in the old pavement propagate upwards and reach the overlay surface. And this is called reflective cracking. The before overlay image shows existing cracks. And in the after overlay image the same cracks are reflected above. This is a common example of overlay distress. Now let us look at the tack coat bonding concept. Tack coat provides a strong bond between the old and new layer and prevents slippage and delamination. If the tack coat is not proper, so the overlay may fail quickly. Now let us look at the 8th topic. 8 important engineering concepts. Overlay reduces tensile stress in old pavement. Higher overlay thickness improves fatigue resistance. Reflective cracking may appear if existing cracks remain untreated. Proper drainage increases overlay life. And these concepts are most important in practical pavement rehabilitation. Now let us look at the 9th topic. No common overlay distress. Reflective cracking, rutting, delamination, slippage cracking, surface undulation. And these failures develop due to poor bonding or improper compaction. Now let us look at the 10th topic. Reflective cracking concept. What is reflective cracking? Cracks in the old pavement propagate upward into the new overlay layer. Now look at its causes. Existing pavement cracks, temperature movement, traffic loading, and the right side image shows this crack propagation. Now let us look at the 11th topic. 1 Practical Site Observation Box. Poor tack coat causes layer separation. Uneven milling creates rough riding quality. Inadequate crack repair reflective cracking lead करता है. Water infiltration weakens overlay performance rapidly. और फील्ड इंस्पेक्शन में यही प्रैक्टिकल डिफेक्ट्स कॉमनली ऑब्जर्व होते हैं. Now let us look at the 12th topic. 1 Quality Control Requirements. QC is very important in overlay construction. Overlay thickness checking, surface level control, compaction testing, temperature monitoring, bond strength inspection, and a proper QC overlay increases durability. Now let's look at the interview question box. Q. Why is overlay provided? Answer. To strengthen existing pavement and improve riding quality. Q. What is reflective cracking? Answer. Cracks from old pavement reflecting into overlay layer. Now let's take a look at the one-shot revision below. Overlay. Pavement strengthening layer. Good surface preparation. Better bonding. Higher overlay thickness. Better structural capacity. Poor drainage. Reduced overlay life. See the final engineering note at the bottom. Proper design. Good material. Strong bonding. And quality construction. All these things ensure long service life of the overlay. And in the next slide, we will understand flexible pavement rehabilitation and pavement maintenance strategies in detail. Slide 23. Shoulders and edge support in flexible pavement. So friends, till now we have understood pavement structure, overlay design, drainage system, and pavement strengthening concepts in detail. But now we will understand one such component of flexible pavement. What many consider a small part. But its role is very critical in practical highway engineering. And that is shoulder and edge support. If the shoulder is not proper, so even strong pavement can start failing from the edge. And this entire concept is explained in detail in this slide. So let us understand the entire slide step by step. 1. Introduction to pavement shoulders. What is shoulder? Shoulder is the portion provided adjacent to the carriageway, which is used for lateral support emergency stopping, and drainage. Now what is the most important thing here? Shoulder supports pavement edges and improves overall pavement performance. See the engineering note below. Proper shoulder support increases pavement life significantly. And this concept is very important in practical highways. Now let us look at the second topic. The functions of shoulders. The major functions of the shoulder. Provides lateral confinement to pavement. Supports edge wheel loads. Improves traffic safety. Assists in drainage. Prevents edge failure. Provides emergency parking space. And the role of shoulder is very critical in highway safety. Now let us look at the third topic. 10 types of shoulders. Different types of shoulders are given here. A. Earthen shoulder. It is constructed from local soil material. Advantages. Economical. Easy construction. Limitations. Erosion risk. Poor durability during rain. B. Granular shoulder. Made from granular materials such as GSB or WMM. Advantages. Better drainage. Improved stability. C. Paved shoulder. Bituminous या concrete surfaced shoulder होती है. Advantages. Higher strength. Better riding quality. Reduced edge deformation. And paved shoulders are preferred in high traffic highways. Now let's look at the right side highway cross section. Here shoulders on both sides of the carriageway are shown. The pavement layers are shown above. Bituminous surface course. Granular base. Granular sub-base. And subgrade. Now the right side drainage role is also shown. Shoulder runoff directs water away from the pavement. Prevents water infiltration. And protects the subgrade from saturation. This is why shoulder drainage is very important. Now let us look at the fourth topic. 4 Importance of edge support. Edge support important. Reduces edge stress concentration. Prevents cracking near pavement edge. Minimizes differential settlement. Improves load distribution. अब नीचे engineering note देखिए. Unsupported pavement edges crack rapidly under traffic loading. And this is the most common edge failure reason in field conditions. 5 Keycap wheel load effect near edge. When traffic moves near the pavement edge, so higher tensile stress is created. If the support is not proper, so what problems will arise? Edge cracking, shoulder settlement, pavement breakdown. The diagram below shows this load effect. Now let us look at the sixth topic. 6 Drainage role of shoulder. The role of shoulder drainage. Directs surface runoff away from pavement. Prevents water infiltration. Protects subgrade from saturation. Now look at the important point below. Poor shoulder drainage weakens pavement edge rapidly. And this is the reason for edge failures. Now let us look at the seventh topic. 7 Common shoulder failures. Edge cracking. Settlement. Erosion. Rutting. Drop-off condition. And these failures are practically shown in the right side images. Now let us look at the eighth topic. Art edge drop condition. What is edge drop? The level difference between the carriageway edge and the shoulder surface is called edge drop. See its effects. Unsafe vehicle movement. Increased accident risk. Pavement edge damage. Now the right side shows correct and incorrect conditions. In the above correct condition, the pavement and shoulder are at the same level. The edge drop condition is shown below, where the shoulder has settled down, and this creates an unsafe condition. Now let us look at the ninth topic. No practical site observation. Poorly compacted shoulders settle quickly. Water stagnation weakens the edge. Heavy vehicles driving on the edge accelerate cracking, create dangerous edge drop. And these observations are commonly found during highway inspection. Now let us look at the 10th topic. Maintenance requirements. Shoulder maintenance is also very important. Shoulder dressing, compaction maintenance, drainage cleaning, edge repair, erosion control. If the maintenance is not proper, so the pavement edge will deteriorate quickly. Now let us look at the 11th topic. 1 Engineering concepts. Proper shoulder compaction improves pavement confinement. Paved shoulders increase structural support. Good drainage prevents edge weakening. Edge restraint improves pavement durability. And these very concepts are extremely important in flexible pavement stability. Now let's look at the interview question box. Q. Why are shoulders important in pavement design? Answer. Because they provide lateral support and improve pavement stability. Q. What is edge drop? Answer. Difference in elevation between pavement edge and shoulder level. Now let's examine the right side edge failure mechanism. First, high tensile stress develops at the edge. Then, a crack initiates, and gradually the crack starts propagating inside the pavement. This is the actual edge failure mechanism. Now let's look at one short revision below. Shoulder. Edge support plus drainage. Poor shoulder. Edge failure. Good compaction. Better stability. Proper drainage. Longer pavement life. See the final conclusion at the bottom. Strong shoulder, strong edge, strong pavement. And in the next slide, we will understand flexible pavement construction considerations and field execution concepts in detail. Slide 24. Construction considerations in flexible pavement. So friends, till now we have understood pavement design, overlay, shoulder support, drainage, and pavement strengthening concepts in detail. But now a very important question arises. If the design is good, material should be good, but the construction quality is poor, so will the pavement give long life? No way. Because one thing is most important in highway engineering, and that is construction quality. And this entire concept is explained in detail in this slide. So let us understand the entire slide step by step. Introduction to construction considerations is essential to achieve designed pavement strength and durability. Important thing here. Even well-designed pavement can fail if the construction quality is poor. See the engineering note below. Construction quality directly controls pavement performance. And this is the most critical concept in practical highway projects. Now let us look at the second topic. Domain construction stages. Flexible pavement construction is completed in several stages. A. Subgrade preparation, clearing and grubbing, soil compaction, moisture control, level checking. Now see the important points below. Weak subgrade causes premature pavement failure. That means the foundation will be weak. Then the entire pavement will become weak. Now let's look at the granular layer construction. GSB laying, WMN laying, moisture conditioning, layer-wise compaction. See the engineering note below. Uniform density is critical for granular layer stability. If the density is not uniform, then settlement and rutting can begin. Now let's look at C, bituminous layer construction. Tack coat application, hot mix transportation, mechanical paving, temperature control, rolling sequence, and temperature control is most important in asphalt construction. Now let us look at the typical flexible pavement construction sequence on the right side. Step 1. Subgrade preparation. Step 2. WMN layer laying. Step 3. Compaction of granular layer. Step 4. Tack coat application. Step 5. Asphalt paving by sensor paver. Step 6. Compaction of asphalt layer. Step 7. Finished pavement. See the important line below. Good construction practice. Good pavement quality. Long service life. And this is the actual highway construction philosophy. Now let us look at the third topic. Teen importance of compaction. Compaction necessary. Increases layer density. Reduces air voids. Improves load carrying capacity. Prevents settlement and rutting. Now take a look at the important concept below. Poor compaction is one of the major causes of pavement distress. And this is the most common issue in field failures. Now let us look at the fourth topic. 4 keycap temperature control in asphalt work. Temperature control is very critical in asphalt paving. Proper mixing temperature. Proper laying temperature. Proper rolling temperature. Now observe the effects of temperature loss. Low density. Segregation. Weak bonding. Surface cracks. Now a temperature range table has also been provided on the right side. Mixing temperature. 150 to 160 degree Celsius. Laying temperature. 130 to 150 degree Celsius. Rolling start temperature. 120 to 140 degrees Celsius. Rolling completion temperature. Above 80 degrees Celsius. And it is important to maintain this temperature window in asphalt work. Now let us look at the fifth topic. 5 construction equipment used. What equipment is used in flexible pavement construction? Motor grader. Sensor power. Vibratory roller. Pneumatic tire roller. Water tanker. Hot mix plant. WMM plant. And proper equipment selection improves construction quality. Now let us look at the sixth topic. 6 layer bonding importance. Proper tack coat ensures bonding between bituminous layers. If the bonding is weak, so slippage failure may develop. See the tack coat bonding diagram below. Tack coat is providing strong connection between old and new bituminous layer. And this improves load transfer. Now let us look at the seventh topic. 7. Traffic management during construction. Traffic management is also very important during construction. Barricading. Reflective signage. Diversion management. Worker safety. See the engineering note below. Improper traffic management creates safety risk and pavement damage. And this is very critical for highway safety. Now let us look at the 8th topic. Art weather considerations. Avoid paving during rainfall. Moisture control during compaction. Temperature monitoring during asphalt work. And asphalt paving should be avoided in rainy conditions. Now let us look at the 9th topic. No common construction problems. Segregation. Improper rolling. Poor drainage slope. Uneven thickness. Cold joints. Inadequate compaction. And these practical problems are shown in the right side images. Now let us look at the 10th topic. Practical site observation. Delayed rolling reduces asphalt density. Excess moisture weakens WMN stability. Improper joint construction causes longitudinal cracks. Poor drainage slope creates water stagnation. And these issues are most commonly seen in site execution. Now let us look at the 11th topic. 11QULITY control during construction. What is checked in construction QC? Field density test. Level checking. Thickness measurement. Temperature checking. Surface regularity checking. And proper QC ensures durable pavement. Now let us look at the 12th topic. 1-2 engineering concepts. Uniform compaction improves pavement life. Controlled construction sequence prevents defects. Good drainage improves durability. Proper layer thickness ensures structural performance. And these are the core engineering concepts in flexible pavement construction. SLID 25. Reclaimed materials in flexible pavement. So friends, till now we have understood flexible pavement design, construction, overlay, and pavement strengthening concepts in detail. But now we will understand a very important modern concept of highway engineering. How to reuse old pavement materials. New strong roads are built. And this concept is called reclaimed materials in flexible pavement. Today this concept is being used very rapidly in sustainable pavement construction. So let us understand the entire slide step by step. Introduction to reclaimed materials. Reclaimed materials are recycled pavement materials, which after processing and quality evaluation are reused in new pavement construction. Now what is the most important thing here? IRC 37 promotes sustainable pavement construction. That is by using recycled materials. Cost also reduces. And the environmental impact is also less. See the engineering note below. Recycling reduces construction costs and conserves natural resources. And this concept is going to be very important in future highway engineering. Now let us look at the second topic. Two types of reclaimed materials. Different reclaimed materials are given here. A. RAP. Reclaimed asphalt pavement. B. Reclaimed granular material. C. Recycled concrete aggregate. D. Industrial byproducts. As fly ash, slag, waste plastic modified mixes. And these materials are used in different pavement layers. Now let us look at the third topic. What is RAP? RAP stands for Reclaimed Asphalt Pavement. It is milled or removed asphalt pavement material, which is used again after processing. Now look at its main components. Aged bitumen, aggregates, mineral filler, Now see the important points below. RAP is widely used in flexible pavement rehabilitation. And RAP has become very common in overlay and rehabilitation projects. Now let us look at the fourth topic. 4 advantages of reclaimed materials. Reduces construction cost. Conserves aggregates and bitumen. Reduces environmental impact. Minimizes waste disposal. Improves sustainability. अब नीचे engineering note देखिए. Recycling improves resource efficiency in highway projects. And this is the main target of sustainable highway construction. Now let us see the right side recycling process. Step 1. Milling of existing pavement. Step 2. RAP collection and transport. Step 3. RAP stockpile yard. Step 4. Crushing and screening plant. Step 5. Mixing plant with virgin material. Step 6. Reuse in new pavement layers. And this is the complete recycling cycle. Now let us look at the fifth topic. 5 uses of reclaimed materials. Where are reclaimed materials used? Granular sub-base. Base course. Bituminous layers. Shoulder construction. Embankment filling. And the percentage is decided according to the project requirement. Now let us look at the sixth topic. 6 recycling methods. Are 3 major recycling methods. A. Hot recycling. Recycled asphalt is used through heating and remixing process. B. Cold recycling. The recycling process is done without heating. C. Full depth reclamation. The entire pavement structure is recycled in place. And this method is being used rapidly in modern rehabilitation projects. Now let us look at the seventh topic. 7 construction procedure. Step 1. Existing pavement milling. Step 2. Collection and crushing. Step 3. Screening and gradation control. Step 4. Mix design preparation. Step 5. Mixing with virgin material. Step 6. Paving and compaction. और recycled pavement construction में gradation control बहुत important होता है. Now let us look at the 8th topic. 8 important engineering concepts. RAP binder becomes stiff due to aging. Proper blending improves mix performance. Excess RAP may reduce flexibility. Gradation control is critical for stability. Now look at the well-graded mix concept below. Better gradation. Better stability. And pavement performance also improves. Now let us look at the 9th topic. No quality control requirements. What is checked in recycled pavement QC? Graduation test. Bitumen content test. Moisture content checking. Density testing. Marshall stability test. Mix temperature control. And these tests are very important to maintain the recycled mix quality. Now let us look at the 10th topic. COMMON problems in recycled pavement. Segregation. Poor blending. Low flexibility. Weak bonding. Moisture damage. And these failures develop due to improper RAP processing. अब 11वां टॉपिक देखते हैं. 1 Practical site observation. Improper RAP stockpiling causes contamination. Excess aged binder increases cracking risk. Poor crushing affects aggregate gradation. Moisture in RAP reduces mix quality. And these issues are most commonly seen in practical projects. Now let us look at the 12th topic. 1. To environmental benefits. Lower carbon emission. Reduced quarrying. Reduced landfill disposal. Sustainable highway construction. And this is the biggest advantage in future green highway projects. Now let us look at the 13th topic. 1.3 IRC 37 considerations. As per IRC, reclaimed material must satisfy structural requirement, durability criteria, gradation limits, mix performance standards. That means recycling will be successful only then, when the quality is proper. Now let's see the interview question box. Q. What is RAP in highway engineering? Answer. Reclaimed asphalt pavement obtained from old pavement recycling. Q. What is the major advantage of recycled pavement material? Answer. Reduction in construction cost and conservation of resources. अब नीचे वन शॉट रिवीजन देखते हैं. RAP. Recycled asphalt material. Recycling. Economical plus sustainable construction. Proper processing. Better pavement performance. Poor blending. Cracking and weakness. Little reminder FRINDS. If you want to learn highway engineering, IRC codes, pavement design, QAQC, DPR, concession agreement and site execution in such an easy way. So please subscribe to the channel and share the video as well, so that correct technical knowledge can reach the civil engineering community. See the final message at the bottom. Recycling today builds strong roads for a better tomorrow. And in the next slide, we will understand pavement rehabilitation and maintenance strategies in detail. SLID 26. Overlay design basics. So friends, by now we have understood the concept of reclaimed materials and overlay. But now we will understand the complete engineering concept of overlay design in detail. How to strengthen old weak pavement and without complete road reconstruction, its service life is extended. And this concept has been explained in detail in this entire slide. So let us understand the entire slide step by step. 1. Introduction to overlay design. Overlay is an additional pavement layer which is provided over the existing pavement. What is its purpose? Restoring structural capacity. Improve riding quality. When the existing pavement becomes weak or distress starts to develop, then the overlay is provided. See the engineering note below. Overlay increases pavement life without complete reconstruction. There is no need for complete pavement reconstruction. Now let us look at the second topic. The purpose of overlay. The main objectives of providing overlay. Strengthening weak pavement. Improvement in riding comfort. Restoration of structural capacity. Reduction in pavement distress. Improvement in surface characteristics. Increase in service life. Now see the important points below. Overlay delays pavement failure economically. And this is the biggest advantage in practical highway rehabilitation projects. Now let us look at the third topic. 3 types of overlay. Here are 3 major types. 8. Flexible overlay. Bituminous layer is provided on the existing flexible pavement. B. Rigid overlay. Concrete overlay is provided over the existing pavement. C. Composite overlay. combination of rigid and flexible strengthening layers. And the overlay type is selected according to the project condition. Now let us look at the fourth topic. Char causes requiring overlay. Overlay needed. Fatigue cracking, rutting, raveling, surface deformation, loss of structural strength, increase in traffic loading, moisture-related damage. And these are the common distresses seen on practical roads. Now let us look at the right side overlay system concept. The new overlay layer is shown above. Below is the existing pavement, and cracks seem to be propagating upward. This is called reflective cracking. Now what is the important thing here? Overlay improves load distribution and reduces pavement stresses. Now let us look at the fifth topic. Part overlay design principle. What does overlay thickness depend on? Remaining pavement strength and future traffic loading. If the pavement is weak, so higher overlay thickness will be required. Look at the engineering formula box below. Overlay thickness. Proportional. Traffic load and structural deficiency. That means thicker overlay is required on heavy traffic roads. Now let us look at the sixth topic. Pavement evaluation before overlay. Pavement evaluation is very important before designing an overlay. Step 8. Visual distress survey. Step 2. Benkelman beam deflection test. Step 3. Traffic analysis. Step 4. Pavement condition assessment. Step 5. Overlay thickness design. Step 6. Surface preparation. And without proper evaluation, the overlay is not successful. Now let us look at the seventh topic. Benkelman beam deflection concept. The purpose of deflection testing. Evaluate pavement structural condition. What does higher deflection indicate? Weak pavement. See the engineering note below. Overlay thickness increases with pavement deflection. That means the more deflection, the greater the overlay thickness. Look at the overlay construction sequence below. Step 8. Existing cracked pavement. Step 2. Milling operation. Step 3. Tack coat application. Step 4. Overlay paving. Step 5. रोलर कंपैक्शन. और यही प्रैक्टिकल ओवरले कंस्ट्रक्शन फ्लो होता है. Now let us look at the eighth topic. Art reflective cracking in overlay. What is reflective cracking? Old pavement cracks. They propagate upward into the new overlay layer. Now look at its causes. Movement in old pavement. Temperature variation. Shrinkage movement. Now look at the solutions. Crack relief layer. Stress absorbing membrane. Proper surface treatment. And reflective cracking is the most common problem in overlay projects. Now let us look at the ninth topic. No surface preparation before overlay. What is done in surface preparation before overlay? Cleaning of existing surface. Crack sealing. Milling operation. Tack coat application. Pothole repairs. Level correction. And surface preparation is very critical for proper bonding. Now let us look at the 10th topic. OVRLY construction procedure. Step 8. Milling and cleaning. Step 2. Tack coat application. Step 3. Overlay paving. Step 4. Compaction by tandem roller. Step 5. Joint finishing. Step 6. Quality inspection. And overlay durability directly depends on the construction quality. Now let us look at the 11th topic. 1. Advantages of overlay. Cost-effective rehabilitation. Faster construction. Improved riding quality. Increased pavement life. Better skid resistance. Improved structural performance. And so overlays are very widely used in highway rehabilitation. Now let us look at the 12th topic. 1. Common overlay failures. Reflective cracking. Debonding. Rutting. Surface undulation. Poor compaction. Water infiltration. And these failures develop due to improper construction. Now see engineering warning below. Improper bonding causes early overlay failure. And this is a very common issue in practical projects. Now let us look at the 13th topic. 1. QUALITY control requirements. What QC checks are done in overlay work? Overlay thickness checking. Temperature monitoring. Compaction testing. Tack coat uniformity. Surface level checking. Joint inspection. Deflection compliance. और प्रॉपर QC ही ड्यूरेबल ओवरले इंश्योर करता है. अब 14th टॉपिक देखते हैं. 1. Practical site observation box. Inadequate cleaning reduces bond strength. Excess tack coat creates slippage failure. Delayed rolling affects compaction quality. Uneven overlay thickness causes riding discomfort. And these observations are frequently seen during field inspection. Now let us look at the 15th topic. 1. Interview question box. Q.Y is overlay provided in flexible pavement? Answer. To restore structural capacity and improve pavement performance. Q. What is reflective cracking? Answer. Cracks from old pavement propagating upward into overlay layer. अब नीचे one shot revision देखते हैं. Overlay. Pavement strengthening layer. Higher deflection. Higher overlay thickness. Reflective cracking. Major overlay problem. Proper bonding. Longer overlay life. Friends, if you want to learn pavement design, overlay design, IRC, 37, QAQC, highway rehabilitation and practical site engineering in such an easy way, so please subscribe to the channel and share the video as well, so that correct technical knowledge can reach the civil engineering community. See the final message at the bottom. Good overlay design plus proper execution. Strong and durable pavement. And in the next slide, we will understand pavement rehabilitation techniques and maintenance strategies in more detail. SLID 27. Shoulders and edge support. So friends, till now we have understood overlay design and pavement strengthening concepts. But now we will understand a very important practical concept of flexible pavement. And that is shoulder and edge support. Because sometimes pavement failure does not happen in the middle of the road. Rather it starts from the edges. And weak shoulder support increases pavement cracking very rapidly. So let us understand the entire slide step by step. 1. Introduction to pavement shoulders. Shoulders are those strips which are provided on both sides of the carriageway. What is their purpose? Providing lateral support. To improve safety. Shoulders improve pavement edge stability. and also increases traffic safety. See the engineering note below. Strong shoulders reduce edge failure and pavement deformation. And proper shoulder construction is very important in highway projects. Now let us look at the second topic. दो functions of shoulders. Shoulders के main functions क्या हैं? Lateral support to pavement layers. Emergency stopping space. Drainage improvement. Prevention of edge cracking. Increased pavement durability. Safety for vehicles. Now see the important points below. Unsupported pavement edges fail rapidly under wheel loading. That means edge support weakened. Then the pavement will start cracking quickly. Now let us look at the third topic. 3 types of shoulders. Here are 3 major shoulder types. A. Earthen shoulder. Shoulder constructed from compacted soil. B. Granular shoulder. Shoulder constructed from GSB or granular materials. C. Paved shoulder. Bituminous or concrete surfaced shoulder. And in heavy traffic highways, paved shoulder is more preferred. Now let us look at the fourth topic. 4 edge support concept. What does edge support? Prevents lateral movement of pavement layers. If edge support is weak, so tensile stresses will develop and edge cracking will start. Now see the engineering concept below. Proper edge support equals better load distribution plus longer pavement life. And this is the main engineering logic of shoulder design. Now let us look at the right side pavement cross section. Here the carriageway, granular layers, subgrade, and shoulders are shown. Now look at the drainage flow arrows. The shoulder slope is directing the water away from the pavement. And this drainage support is very important for pavement protection. Now let us look at the fifth topic. 5 pavement edge failure. What are the common edge failures? Edge cracking, shoulder settlement, edge drop, raveling near edge, water infiltration, surface deformation. And due to weak shoulders, these failures are seen in the field. Now let us look at the sixth topic. 6 causes of edge failure. Why do edge failures develop? Poor shoulder compaction, water accumulation, heavy wheel loading near edge, weak shoulder material, differential settlement, inadequate drainage. Now see the engineering warning below. Water near pavement edge accelerates pavement damage. And this problem increases the most during the monsoon season. Now let us look at the seventh topic. 7 importance of paved shoulders. The advantages of paved shoulder. Better structural support. Reduced pavement deformation. Improved riding quality. Better drainage performance. Reduced maintenance requirement. Increased pavement life. And paved shoulders are very common on expressways. Now let us look at the 8th topic. 8 wheel load distribution concept. Wheel loads pass through pavement layers. S transfer takes place towards the holder area. Strong shoulders resist lateral stresses. See the engineering note below. Shoulder stiffness directly affects pavement edge performance. And this is the reason why shoulder quality is very important. Now let us look at the 9th topic. No drainage and shoulder performance. What does proper drainage prevent? Water infiltration into pavement edges. Now look at the drainage requirements. proper cross slope, side drain provision, shoulder compaction, prevention of water stagnation, and poor drainage accelerates edge failures. Now look at the right side comparison. Paved shoulder, high strength, better support, less deformation, better drainage. Earthen shoulder, low strength, more deformation, water retention, more maintenance, and this practical difference is visible in highway projects. Now let us look at the 10th topic. Construction procedure of shoulders. Step 1. Surface preparation. Step 2. Material spreading. Step 3. Moisture conditioning. Step 4. Roller compaction. Step 5. Edge alignment checking. Step 6. Slope finishing. And shoulder slope accuracy is very important for drainage performance. Now let us look at the 11th topic. 1 compaction requirements. Shoulder compaction में क्या important है? Proper density achievement, uniform moisture content, edge compaction control, prevention of loose shoulder material. Now see the engineering note below. Inadequate shoulder compaction causes differential settlement. And this is the common issue in field projects. Now let's look at the 12th topic. 1-2 practical site observation. Loose shoulders create edge drop conditions. Poor drainage softens shoulder material. Uneven shoulder level affects vehicle safety. Weak shoulder support increases edge cracking. And these observations are frequently seen during highway inspection. Now let us look at the 13th topic. 1-3 QULITY control requirements. What QC checks are done in shoulder construction? Shoulder width checking, compaction testing, moisture content control, cross slope verification, density testing, edge alignment checking, drainage inspection, and proper QC ensures durable shoulder performance. Now let us look at the 14th topic. 1-4 IRC design considerations. What is important in shoulder design according to IRC? Adequate shoulder width, proper shoulder slope, strong edge confinement, drainage compatibility, material suitability, and shoulder design should always be coordinated with pavement drainage. Now let us look at the 15th topic. 1-5 interview question box. Q. Why are shoulders important in flexible pavement? Answer. Shoulders provide lateral support, improve drainage, and increase pavement life. Q. What causes pavement edge failure? Answer. Weak edge support, poor drainage, and inadequate shoulder compaction. अब नीचे वन शॉट रिवीजन देखते हैं. Shoulder, edge support layer, weak edge support, edge cracking, proper drainage, better edge stability, paved shoulder, higher pavement life. Friends, if you want to learn pavement engineering, highway design, drainage, overlay design, QA/QC and practical site engineering in such easy language, so please subscribe to the channel and share the video as well, so that correct technical knowledge can reach the civil engineering community. See the final message at the bottom. Strong shoulder, strong edge, strong pavement, and in the next slide, we will understand pavement maintenance and rehabilitation concepts in more detail. SLID 28 Construction considerations. So friends, till now we have understood pavement design, overlay, shoulder support, and rehabilitation concepts in detail. But now we will understand that most important factor can make even a good design fail. And that is construction quality. Because a very important thing is said in highway engineering. Good design fails if construction quality is poor. And this entire concept is explained in detail in this slide. So let us understand the entire slide step by step. 1. Introduction to construction considerations. Proper construction practices are very important to achieve vehicle strength, durability, and long service life. If the construction quality is poor, then the pavement will soon show distress, as cracking, rutting, settlement, surface failures. See the engineering note below. Good design fails if construction quality is poor. And this is the biggest challenge in practical projects. Now let us look at the second topic. The importance of construction. How does construction quality affect pavement performance? Proper layer bonding, uniform compaction, adequate strength development, better riding quality, reduced maintenance requirement, increased pavement life. अब नीचे important point देखिए. Construction defects directly reduce pavement performance. And this is the reason why QA/QC is so important. Now let us look at the third topic. 3 major construction stages. What is flexible pavement construction sequence? Step 1. Subgrade preparation. Step 2. Granular layer construction. Step 3. Prime coat application. Step 4. Bituminous layer paving. Step 5. Compaction process. Step 6. Joint finishing. Step 7. Quality inspection. And this complete sequence is shown in the right side construction scene. Here hot mix plant, dumpers, paver machine, tandem roller, pneumatic roller, and water tanker are visible. And this is the actual field construction setup. Now let us look at the fourth topic. 4 subgrade construction considerations. Subgrade preparation में क्या important है? Proper compaction, moisture control, removal of soft spots, density achievement, surface level checking, drainage arrangement. Now see engineering warning below. Weak subgrade causes settlement and cracking. And pavement foundation failure starts from here. Now let us look at the fifth topic. 5 granular layer construction. What is important in GSB and WMM layers? Uniform material spreading, controlled moisture content, layer-wise compaction, cross-slope maintenance, thickness control, and proper gradation and density are very important for granular layer stability. Now let us look at the sixth topic. 6 bituminous layer construction. Which factors are critical in bituminous paving? Temperature control, proper mixing, uniform paving speed, proper rolling sequence, joint compaction, prevention of segregation. See the engineering note below. Temperature variation affects compaction and bonding quality. And temperature control is the most critical parameter in asphalt paving. Now let us look at the seventh topic. 7 compaction considerations. Here are the different types of rollers. Vibratory roller, Tandem roller. Pneumatic tire roller. Now look at the compaction objectives. Density achievement. Air void reduction. Strength improvement. Prevention of deformation. And inadequate compaction is the biggest cause of pavement distress. Now let us look at the 8th topic. Art segregation problem. What is segregation? When coarse and fine aggregates separate, so segregation develops. See its effects. Weak pavement zones. Uneven texture. Reduced durability. Water infiltration. Now look at the solutions. Controlled material handling. Uniform paving operation. Proper plant calibration. And the segregated surface is clearly visible in the right side image. Now let us look at the 9th topic. No joint construction considerations. Joint construction में क्या important है? Proper longitudinal joint compaction. Clean joint face. Temperature matching. Adequate overlap. Now see the engineering warning below. Weak joints become early failure locations. And longitudinal joint cracking is a very common problem in field projects. Now let us look at the 10th topic. WEATHER considerations during construction. In which weather conditions should construction be avoided? Heavy rainfall. Excessively low temperature. Strong wind conditions. Now see the important points below. Ensure dry surface condition before paving. And paving on a wet surface weakens the bonding. Now let us look at the 11th topic. 1 Drainage considerations. Why is drainage important during construction? Proper side drain provision. Prevention of water stagnation. Shoulder drainage control. Cross slope maintenance. See the engineering note below. Water infiltration is a major reason for pavement deterioration. And poor drainage rapidly reduces pavement life. Now let us look at the 12th topic. 2 Construction machinery used. Which machinery is used in flexible pavement construction? Hot mix plant. Sensor power. Vibratory roller. Pneumatic roller. Water tanker. Motor grader. Milling machine. And proper machinery selection improves construction quality. Now let's look at the 13th topic. 3 Common construction defects. Low compaction. Surface undulation. Segregation. Improper joint finishing. Bleeding. Cracking. Raveling. And these failures develop due to improper construction practices. 4 Practical site observation. Delayed rolling reduces density achievement. Excess moisture weakens granular layers. Uneven paving speed creates surface irregularity. Improper temperature control affects bitumen bonding. And these are the issues that are most commonly seen during field inspection. Now let us look at the 15th topic. 15 QULITY control requirements. What tests and checks are done in construction QC? Density testing. Temperature monitoring. Layer thickness checking. Bitumen content checking. Surface level verification. Gradation testing. Joint inspection. Smoothness testing. And proper QA/QC is what ensures a durable pavement. Now let's look at the 16th topic. 16 Interview question box. Q. Why is compaction important in pavement construction? Answer. Compaction improves density, strength, and pavement durability. Q. What is segregation in bituminous work? Answer. Separation of coarse and fine aggregates causing weak pavement zones. Now, let's look at the additional concepts below. Temperature control. Mixing temperature. 160 degrees Celsius to 170 degrees Celsius. Laying temperature. 130 degrees Celsius to 150 degrees Celsius. Rolling temperature. 90 degrees Celsius to 120 degrees Celsius. Now look at the cross-slope sequence. Proper rolling sequence ensures uniform compaction. And camber provides 2% to 3% drainage. Let's look at one short revision at the bottom. Proper compaction. Strong pavement. Poor drainage. Pavement damage. Segregation. Weak zones. Temperature control. Better bituminous performance. Friends, if you want to learn highway construction, QA/QC, pavement design, IRC standards and practical site engineering in such an easy way, so please subscribe to the channel and share the video as well, so that correct technical knowledge can reach the civil engineering community. See the final message at the bottom. Good construction practice. Long-lasting pavement. And in the next slide, we will understand pavement failures and distress mechanisms in more detail. SLID 29. Construction considerations in flexible pavement. So friends, till now we have understood the entire concepts of pavement design, drainage, overlay, shoulders, and recycled materials. But now we have reached that most important stage, where actual pavement performance is decided. And that is construction quality. Because one thing is always remembered in highway engineering. Good design can fail due to poor construction. And this entire concept is explained in detail in this slide. So let us understand the entire slide step by step. 1. Introduction to construction considerations. Pavement performance heavily depends on proper construction practices and field quality control. If the construction quality is poor, so even a good design can fail. That means pavement life does not depend only on design. Execution quality is equally important. See the engineering note below. Construction quality directly controls pavement durability and service life. And this is the most critical concept of field engineering. Now let us look at the second topic. To recap main objectives of proper construction. The main objectives of proper pavement construction. Achieve required pavement strength. Ensure proper compaction. Maintain layer thickness. Improve riding quality. Prevent premature pavement distress. Achieve design life performance. Now look at the important point below. Uniform construction quality ensures uniform pavement performance. If the quality is not uniform, so the pavement will develop weak zones. Now let us look at the third topic. 10 important construction stages. Pavement construction sequence is given here. A. Subgrade preparation. Soil compaction. Moisture control. CBR compliance. Level and camber checking. If the subgrade is weak, so the entire pavement structure will become weak. Now let's look at B. BGSB construction. Aggregate gradation control. Proper spreading. Water sprinkling. Vibratory compaction. Now let's look at CWMM construction. Plant mixing, moisture content control, mechanical laying, density achievement. Now let's look at D. Bituminous layer construction, temperature control, tack coat application, sensor power laying, rolling sequence. And this is the complete pavement construction process. Now look at the construction sequence diagram on the right side. This is showing the complete layer by layer execution. 1. Subgrade preparation. 2. GSB laying and compaction. 3. WMN laying and compaction. 4. Tack coat application. 5. Bituminous paving. 6. Rolling. 7. Finished pavement. And this is the actual sequence of highway field execution. Now let us look at the fourth topic. 4. Compaction requirements. Increases both pavement strength and durability. Now rollers are also provided here. Vibratory roller, tandem roller, pneumatic tired roller. See the engineering note below. Inadequate compaction is one of the major causes of pavement failure. And this is seen in practically every highway project. Now let us look at the fifth topic. Part moisture control concept. Moisture content directly affects compaction. Optimum moisture content improves density. Excess moisture weakens layers. Low moisture prevents proper compaction. Now look at the graph below. Maximum dry density is achieved at ONC. And this is the soil compaction principle. Now let us look at the sixth topic. 6. Layer thickness control. Layer thickness should always be as per the design requirement. If the thickness is uneven, so stress concentration will develop. Now see engineering warning below. Thin pavement layers fail rapidly under traffic loading. And this is why under thickness pavement shows distress quickly. Now let us look at the seventh topic. 7. Keycap temperature control in bituminous works. Temperature control is very critical in bituminous construction. Proper mix temperature during transport. Controlled paving temperature. Rolling within specified temperature range. Avoid temperature segregation. If the temperature drops, so both compaction and bonding get affected. Now the thermometer diagram is also showing the same. Now let us look at the eighth topic. 8. Drainage considerations during construction. Drainage management is very important during the construction stage. Shoulder slope maintenance. Side drain construction. Prevention of water stagnation. Protection during monsoon. If there is water stagnation, so the layer strength starts reducing. Now let us look at the ninth topic. No common construction defects. What are construction defects? Segregation, honeycombing, poor joint construction, surface undulation, low density, edge failure. And these defects are shown in the right side images. Now let us look at the 10th topic. QULITY control requirements. Ensure construction quality. Field density testing. Thickness measurement. Graduation test. Temperature monitoring. Level checking. Camera verification. Bitumen content test. And these tests are mandatory in highway projects. Now let us look at the 11th topic. 1. Practical site observation box. Common observations found during field inspection. Delayed rolling reduces asphalt density. Uneven moisture causes weak WMM patches. Poor edge compaction leads to shoulder failure. Inadequate tack coat reduces layer bonding. And these actual site problems reduce pavement performance. Now let us look at the 12th topic. 1-2 Safety considerations during construction. Construction zone safety is also equally important. Traffic diversion management. PPE for workers. Equipment safety checks. Night work illumination. Barricading and signboards. And improper safety management increases accident risk. Now let us look at the 13th topic. 1-3 Engineering concepts. Uniform compaction improves load distribution. Proper bonding increases structural continuity. Good drainage improves pavement life. Temperature affects asphalt workability. And this is the complete logic behind pavement construction engineering. Now let's look at the 14th topic. 1-4 Interview question box. Q. Why is compaction important in pavement construction? Answer. Because proper compaction increases strength and reduces deformation. Q. What happens if moisture exceeds OMC? Answer. Layer strength and density reduce. Now let's look at the one-shot revision section at the very bottom. Proper compaction, better pavement strength. Good moisture control, higher density. Proper temperature, better asphalt performance. Poor construction, early pavement failure. And look at the final message at the very bottom. Good construction today delivers smooth roads tomorrow. And this is the complete construction consideration concept. And now on to the next slide. We will understand flexible pavement quality control and inspection, where field testing, density control, thickness verification, and acceptance criteria will be understood in detail. SLIDs. Flexible pavement failure modes. So friends, till now we have understood flexible pavement design, construction, drainage, overlay, and quality practices in detail. But now we've reached that topic is most important for every highway engineer. And that is flexible pavement failures. Because the main objective of pavement engineering is not just to build roads. Rather, pavement failures have to be prevented. And this entire concept is explained in detail in this slide. So let us understand the entire slide step by step. 1. Introduction to pavement failures. Pavement failure occurs when the pavement starts losing its structural strength or riding quality. Failures develop. Traffic loading. Environmental conditions. Poor drainage. From construction defects. See the engineering note below. Most pavement failures begin from small defects and worsen over time. That means it starts small. But if there is maintenance delay, the entire pavement may fail. Now let us look at the second topic. Though major failure categories. Flexible pavement failures are divided into 3 categories. A. Structural failure. When pavement strength becomes insufficient. B. Functional failure. When riding comfort and safety are affected. C. Material failure. When failure develops due to poor material quality. And this classification is very important in the field of engineering. Now let us look at the third topic. Teen fatigue cracking. Develops due to repeated wheel loading. Repeated tensile stress produces interconnecting cracks. Its appearance resembles an alligator or crocodile crack pattern. Now look at the causes. Repeated traffic loading. Weak pavement structure. Inadequate thickness. Poor drainage. Now see engineering warning below. Fatigue cracking indicates structural weakness. And this is the most common structural failure of flexible pavement. Now let us look at the fourth topic. Char rutting failure. Is longitudinal depressions formed in the wheel path. Now look at the causes. Weak subgrade. Poor compaction. Excess bitumen. Heavy axle loads. Now see the effects. Water accumulation. Riding discomfort. Increased accident risk. And rutting can be very dangerous during rainy season. Now let us look at the fifth topic. Panch raveling failure. In raveling, aggregate particles start coming out from the pavement surface. Now look at the causes. Poor bitumen bonding. Aging of bitumen. Low compaction. Segregation. Now see the effects. Rough surface. Reduced skid resistance. Dust generation. And this is the major sign of surface deterioration. Now let us look at the sixth topic. Chhe bleeding failure. Bleeding occurs when excess bitumen comes up to the pavement surface. Now look at the causes. Excess bitumen content. Low air voids. Heavy compaction. High temperature. Now see the effects. Slippery surface. Skid hazard. Now see engineering warning below. Bleeding reduces vehicle tire grip. And this problem is more visible in high temperature corridors. Now let us look at the seventh topic. Saath pothole formation. Potholes are ball-shaped depressions, which develop due to pavement surface disintegration. Now look at the causes. Water infiltration. Weak pavement layers. Traffic impact. Untreated cracks. Now see the effects. Vehicle damage. Safety hazard. Rapid pavement deterioration. And potholes are the most common issue in field complaints. Now let us look at the eighth topic. Arch edge failure. Edge failure refers to cracking and breaking near the pavement edge. Now look at the causes. Weak shoulder support. Poor drainage. Edge loading. Shoulder settlement. See the engineering note below. Unsupported edges fail rapidly under traffic. And this problem is very common in narrow shoulder roads. Now let us look at the ninth topic. No longitudinal and transverse cracking are two important crack patterns. Longitudinal cracks develop parallel to the pavement center line, whereas transverse cracks develop perpendicular to the traffic direction. Now look at the causes. Temperature variation. Shrinkage movement. Reflection cracks. Construction joints. And climate variation accelerates these cracks. Now let us look at the 10th topic. Reflexivity cracking. Reflection cracking then develops when existing pavement cracks propagate up to the overlay layer. Now look at the causes. Movement in old pavement. Temperature stress. Shrinkage movement. Now look at the control measures. Crack relief layer. Stress absorbing membrane. Proper overlay design. And this is a very critical issue in overlay projects. Now let us look at the 11th topic. 1. Water-related failures. Water is considered the biggest enemy of pavement. Now look at water-related failures. Stripping, moisture damage, loss of bond, subgrade weakening. Now see engineering warning below. Water is one of the biggest enemies of flexible pavement, and poor drainage drastically reduces pavement life. Now let us look at the 12th topic. 1-2 failure due to poor construction. Poor construction quality is also a major cause of pavement failure. Now look at the causes. Inadequate compaction, segregation, improper layer thickness, poor joint construction, temperature control failure, and most early failures in highway projects develop from construction defects. Now look at the pavement failure progression below. Initial stage, minor cracking, intermediate stage, crack widening and deformation, final stage, potholes and structural collapse. And this is the actual pavement deterioration cycle. Now let us look at the 14th topic. 1-4 Maintenance and prevention measures. Be done to control failures. Timely crack sealing, drainage improvement, proper compaction, periodic overlay, shoulder maintenance, surface renewal, and preventive maintenance is always more economical than rehabilitation. Now let us see the practical site observation. 1-5 Practical site observation. Water stagnation accelerates pavement damage. Poor shoulder condition increases edge cracking. Delayed maintenance enlarges potholes. Low density causes early rutting. And these are actual highway field observations. Now let us look at the 16th topic. 1-6 IRC-based preventive measures. For pavement protection as per IRC guidelines, adequate pavement thickness, proper drainage design, quality construction, timely rehabilitation, proper material selection. It is very important. Now let us look at the 17th topic. 1-7 Interview question box. Q. What is fatigue cracking in flexible pavement? Answer. Interconnected cracking caused by repeated wheel loading and tensile stress. Q. What causes rutting failure? Answer. Weak pavement layers, poor compaction, and heavy traffic loading. Now let's look at the one-shot revision section at the very bottom. Fatigue cracking, structural weakness, rutting, permanent deformation, bleeding, excess bitumen, water damage, major enemy, proper maintenance, longer pavement life. If found this CI engineering lecture useful, so like the video, share it, and definitely subscribe to the channel. Because here you get highway engineering, pavement design, IRC concepts, and field practical knowledge in complete detail. And now on to the next slide. We will understand flexible pavement quality evaluation and performance monitoring, where roughness, deflection, condition survey, and pavement performance assessment will be understood in detail. Okay friends, till now you have completed part 3. Let's do a quick recap. You have understood the pavement design principles. Fatigue and rutting failure became apparent. Understood the pavement thickness selection logic of overlay design and shoulder support became clear. And also understood construction practices and quality control. Now you have an understanding of both design and failure. And remember, proper design and proper construction together give long pavement life. Now the next step is clear. Now we will move towards part 4. Because now we will understand the complete design procedure and numerical. Part 4, we will discuss step-by-step IRC, SATI's design process, numerical calculation and final revision. That means now all the learning will be complete. And one important thing, if the calculation and code are not clear, then the design will not be able to be applied practically. That's why part 4 is the final and most important part. So now let's go straight to the next video. Part 4 and complete the entire series. If you find this series useful, so subscribe to Civil Engineering Infrastructure. If you liked the video, please like it. Write your doubt or feedback in the comment section. For similar content, share it with your friends and colleagues. Follow us on YouTube @CivilEngineInfra. Also connect on Instagram @CivilEngineInfra. Connect on Facebook and LinkedIn by searching Civil Engineering Infrastructure. Here you will get highway engineering, pavement design, IRC concepts and site practical knowledge. Let's move on to part 4.